We're down here in RTP, North Carolina, checking out NetApp's latest offering. At NetApp Insight last year, they launched a brand new version of the ASA, the All-SAN array. All-flash array comes in a number of different models, capacities, and performance profiles depending on what the customer needs. What ASA delivers is block storage in a simplified package that's easy for general IT administrators to pick up and deploy. We're going to hopefully prove that out as we send Kevin off to deploy one of the ASA models with no guidance, no training wheels, and no support whatsoever. Apparently at Insight they had executives doing it, so if executives can do this with very little guidance, I'm quite confident Kevin can. So we'll see how fast he can deploy this ASA. One of the things we really want to explore today, though, is what makes ASA special. So we saw the hardware at Insight, we talked to some of the execs there about what the product does, what it offers, but ASA now is really relaunching as a simplified block storage offering for NetApp's customers. ONTAP has been NetApp's staple for a very long time now, and customers that have been on ONTAP, the AFF arrays now, they love all the tunability and all the customizations available under the covers with ONTAP, all the data protection, all those great features. But for IT generalists or those wearing multiple hats within a smaller organization, simplicity is becoming more and more important for block-specific workloads. That's where ASA comes in, taking all the heritage of NetApp's ONTAP and making it simpler to deploy, simpler to consume and manage. Today's goal is going to be to get hands-on with the ASA arrays, to look at the hardware, what makes them special, and really look at the deployment process where Kevin takes it from probably in pieces, if I know Kevin, to rack, to power, and deploy those initial bits of shared storage. They also have a number of tools that make it easy for IT generalists to keep an eye on the NetApp estate. The ASA is part of that heritage that includes all the other ONTAP arrays. So we'll take a look at this Grafana interface, all the visualizations that they've got there. Importantly though, we came down from Cincinnati where we just got 1.5 feet of snow. In North Carolina, while it's sunny today and seemingly serene, is not immune to the cold. It's cold and icy down here. You can see the snow in the background. We're going to get inside and get into the warm confines of the noisy data center to explore the ASA and all the capabilities that it contains.
So NetApp's always been known for, I think, more for unified storage, for doing everything on a single array. And what we find is that there are some customers and applications that want to consume just block storage.
Okay.
They want to segment their block from their file, and ASA is fine-tuned to do that. So this is really, you have an application that manages it. We're especially targeting VMware and database in this iteration. So everything is very simple when you come from that approach. So it's really just a new way of approaching it, really targeting simplicity.
So when I think about ASA in my mind, what I think of is a trimmed down or a more efficient version of ONTAP just for block that's easier for IT generalists to administer. Is that fair, or is that boiling it down too far?
I think you're absolutely right. So I mean, think about it. I hate to say like ONTAP has always been thought of as like a Swiss Army knife, but it kind of literally does file, block, and object.
Right.
With this, we've actually created a scalpel for block. I mean, it does exactly what you need to, and the benefit of that means that it's incredibly simple. It does one thing. You're able to literally provision it in seconds, protect in just a few clicks. Things like snapshots and replications are incredibly easy to do.
Right.
We've got some really cool proof of concepts running here. We've seen a big uptake, especially on VMware and database.
Sure. Yeah, well, I mean, that's where block's going to reign supreme. And I guess this gives you access to a bigger portion of the market where ONTAP we all know as, gosh, I mean, been around forever, hardened, and for the seasoned ONTAP administrator, you can get in there and tune everything. 100%. From your LUNs to your protection policies to everything.
Right.
In ASA, you're streamlining that, you're making it a little bit easier and like I said, more approachable for generalists, but for a whole market that thought maybe ONTAP was too much for them to consume, this addresses that concern.
Yeah. I mean, so my background, I came from an application that really needed all the features of ONTAP. I needed to replicate a database and a file store and keep them in sync. But what I find was, especially talking with like Oracle administrators, they just want to have Oracle manage the storage. And so they want to go in and use the tools they're familiar with, and they really just want storage to get out of their way. That's exactly what ASA does.
Well, you mentioned VMware too, and obviously that's the operating system of choice for most businesses, most enterprises. But what you get in there is all the capabilities of the full ONTAP suite, which is another thing that's important to understand, that when you look at ASA, you're not just getting a abbreviated ONTAP. You're
Right.
getting a dedicated tuned block version of ONTAP, but
Exactly.
still all the other heritage
You're
that
getting
comes with
all
it.
the benefit, the hardware engineering, the security patching, everything's on there. It's not a fork or a branch.
Right.
Literally just a different personality of ONTAP. It's kind of an evolution.
Well, I think that's important too, because as you look at the storage market, it's not as if you've got another stack, another stack, another stack,
Right.
another stack, and you have to support all these things and iterate code differently. In this case, it's still, does it have the same release cadence as ONTAP? Like
100%.
the
It's
dot releases each
Yep.
of those?
Each version of ONTAP that comes out supports both our classic unified and ASA right out of the box. It's not, there's no separate point releases.
And so with your customers that are already ONTAP customers using the all-flash, traditional storage that we come to know and love that's unified, do you see them picking this up as well, or is this really for net new ONTAP customers that only want the block?
Well, I would say for existing NetApp customers, often what we find is those customers essentially have like two branches. You've got a NAS team and you've got a SAN team.
Right.
This opens the door to talk to the SAN team.
Okay.
But it also is our foot in the door for people who have never considered us for block before. Especially when we talk to partners, there's a lot of partners that say NetApp is for file and Company X is for block. We are now in there for block as well, and we're really proving to them that we are serious about the space.
So it gives you more robust portfolio.
Yep.
We talked about it lets you hit some customers that you may not have been able to before, and you've got some fundamental engineering changes in this. So I know I boiled it down to a very small point of it's a block optimized ONTAP, but there's more with the pathing, which we'll get into some of that over the course of today. But it's less, but it's also more. It's kind of hard to characterize.
The way we've been saying is, customers want simplicity, but at the same time they want all the benefits and all the power of something like your classic block frame array.
Right.
We're giving you that symmetric active-active pathing. So really you get those benefits without having to compromise on simplicity. And it's now in this new modern scale-out architecture, right? We're able to add tons of nodes into the system. It's really, we've just taken a lot of compromises out that people had to kind of, felt they had to make a choice of before.
And so we're going to tear into the hardware too, but the hardware platforms between ASA and AFF, same thing, right?
Same thing. Literally the same box, just a different hardware personality that gets from the factory.
So overall, a more simplified operating system or operating environment. New users should be able to come in there pretty quickly, provision the box, which we will also do. We're going to send Kevin down that path of taking, I think the one over our shoulder here, from rack and power to provisioning storage. That should be pretty straightforward and simple. I know we're going to look at some of I talked about the overlap with ONTAP. The same monitoring tools work there. You've got that Grafana interface, which is pretty neat, available through GitHub. That is a great visualization for what's going on with your array. We talked about the VMware integration. There's a lot going on there, but I know the guys are excited to get in there, grab that thing, tear it apart, put it back together, and then turn it back on and see what the experience is like of standing that system up from zero to provision.
Yeah, I'm excited to see you guys go at it.
All right, so we're in the fishbowl here in NetApp Building 1 and RTP, and this has got some of the customer-facing racks where they can bring people in, show them what they've got going on. None of that matters to you guys, but it matters to us because that means we've got access to the ASA A90 in this lab. I know you're looking forward to tearing it apart and then eventually setting it back up again.
Yeah, we're going to look at some of the internal components, put it back together, provision as a new device, which should be pretty easy.
Yeah, so that's the plan. And from a hardware perspective, the ASA is the same as the AFF, which is kind of interesting. I mean, we think about them targeting a different market with this block-only storage, but same hardware platform, which simplifies the entire operation. And I know we're not going to spend a ton of time in here, but when we got here, it was like 27 degrees. So this is one of the few times I don't mind being in a lab a little bit longer than usual.
Although it is chillier in here than the rest of the building because it's air conditioned.
Yeah, I'm used to ours, which is 87 degrees at all times, which is a little different. This is a proper customer-facing data center. Glass on 3 sides and all sorts of, I think I counted 12 NetApp racks of gear in here.
We're here with NetApp at their RTP office, and I'm standing with Scott Bell, who's going to give us an introduction on the ASA A90 hardware up in the flesh.
Absolutely. And one thing that you'll notice about this system, you might say, well, that looks like an AFF A90, because it is based on the same hardware system. It's just a different software configuration that we have available. It is still the same 4U chassis with the same width, same chassis depth, same internal ability of 48 internal SSDs that are all NVMe attached, but in the back, is the I/O that sets it apart from the AFF A800, ASA A800 that was previously available.
Well, that sounds great. And from the serviceability side, let's start taking this thing apart so we can look at the internal components.
Absolutely. So what you do is you grab hold of these two black handles here, pull down, and the whole unit disengages from the chassis. As you can see up here in the front, we have a collection of 6 hot swappable fans. So in case one of these fails, you just grab, squeeze, lift it out.
Yep.
There, get your replacement, drop it
Pretty
back
easy
in.
to take apart.
Pretty easy. Under here, you also find the NVRAM battery, but you'll also notice provide a convenient map of what DIMMs go where in which configuration, where the NVRAM battery, where the coin cell is. You simply lift this plastic baffle here, and you have access to the CPUs, not that you ever have to touch those, system DIMMs, should they ever have to be replaced, and the coin cell battery is conveniently located over here on the right-hand side.
Now, I don't see a boot drive. Is there one inside this platform?
So the boot media, you're right, it is not contained inside this, underneath of this baffle here. It's actually back here on the management module. So if you look at the back, you got 2 PSUs per controller, and you got this management module over here that has a selection of ports on it, and go into those. And the boot media is actually here, so you don't actually have to tear apart the whole PCM should this thing prematurely burn out or wear down.
Okay.
On the back of this module, you'll see that we have USB Type A, that can be used to load ONTAP images or rescue core files. We have a USB-C console port, and we also have a UART for the console port. And this is also the baseboard management controller, or BMC, so that way you have remote console access should you need it. And this just re-engages back in. You hear a click, and it's okay to re-engage the arm.
So looking at the back right now, I see some SAP Plus and a QSAP Plus adapter card. What are some different options that you guys offer on the ASA A90?
Oh, great question. And for clarity, these are 100 gig adapters, so that means they're QSAP 28. They have a higher pin count here. But you also have access to 4-port SAP 28 ports, which could be 10 or 25, depending on what cable you plug into. 64 gig Fibre Channel, which we all know is Fibre Channel will step down 2 generations, depending upon the SAP that's installed. And then we also have access to a 10 gig base T module, should in case you need that type of connectivity for your data center. To get a better look, say this one over here on the far left, this is one of the 100 gig modules.
Now, the connector looks pretty familiar. Is that a OCP standard?
It absolutely is. As I mentioned before regarding I/O density, we couldn't quite do that with even half-height PCIe slots because the PCIe slot takes its own height on the PCM, and then you plug the adapter into this. The way that we achieve this is by using a new standard called the Open Compute Platform, or OCP Revision 3, and that's what allows us to gain this I/O density that we have here.
So that's pretty cool. Let's get this thing back together so we can start provisioning the lab.
Absolutely.
So I'm here with Mike, and we've discovered the newly set up and not yet configured A90. So we're going to go through the setup, and it should be pretty quick and easy.
Very simple.
All right, so I'm going to give it a trusty password 123 for its password, which hopefully does not stay in this state forever. Cluster name, we're just going to call it the StorageReview A90, and management address and this information. Generally, you work in an environment, you've already had these IP addresses configured, and I have a little sheet of IP addresses to use that'll work in this environment. Everything here, it's pretty easy, and usually a lot of these arrays, you'll hop into these interfaces and it's minimal clicks, but setup time varies. Sometimes you'll have interfaces where you'll click continue and 20, 30 minutes later it might finish. I'm kind of curious how long this one goes through. And for simplicity's sake, I'm going to skip over the network services. We're going to keep these on default, although you can turn these on or turn on hardware encryption if you wish. So we're going to leave that unchecked. Continue, continue, and initialize. I will not save my password since it was very easy. So right now it's saying the cluster is being configured. Process might take more than 5 minutes to complete, so we'll just see where it goes. So in this process, is it just discovering all the available drives, initializing them, and getting them clean for the initial setup?
Discover the drives, create RAID groups, create aggregates for the 2 controllers, and basically set up the basic environment.
So does this setup, for when it's creating the aggregates, is it going to apply a default RAID configuration, or will that be a setup, a process that the user can configure themselves?
It is completely automagically done for you.
Okay.
You could not change it, nor do we want you to even worry about it. It's already done to best practice.
Okay, and for, does the best practice change depending on the amount of drives in the system, going from like a RAID 5-ish variant to RAID 6 or RAID DB type of
So
configuration?
everything is going to be, essentially, it is RAID DP, which is like RAID 6, except for with persistent parity drives. You have specific drives that are parity as opposed to striping across, a floating stripe across a set of drives, which is what
Okay.
you'd have with RAID 6.
Okay, cool. Okay, so the setup has taken place, and now we can finally log into the platform to start configuring things. This array, we're given about just under 70 terabytes of available storage. Does everything look nice and clean and expected in this particular state?
Yep. You basically, you have an array where you do not have any storage set up yet.
Okay.
I will give you one tip. Follow the blue buttons.
The biggest blue button right now is the configure protocols. Going to configure the IP addresses, subnet group, and broadcast domain. We're going to use this SR domain there and click add. Click that group and save.
And see the lifts you just created?
Yeah.
Right there.
Okay, now we're going to do add storage unit. That's biggest blue button. We're going to do something just maybe 100. Well, this would be like a boot drive of some sort.
And you also can pick scale. Do you want meg, gig, terabytes?
Yeah,
Any of the above.
we
It's
make a
fine.
very small,
Yeah, I
small
don't-
one. So we have a jump box that is a Linux host, and for this we have a NQN. So I'm going to copy and paste this
Yeah.
because most people don't want to type
Copy
out
and paste is absolutely your friend here.
30-digit NQN. Paste that in there, click add, and that's just going to run in the background.
And storage unit was added. Now, if you want to go take a look at what you just added, you can go to storage. And there's your storage unit, so you can click on that if you want to find out more about it. There's a little hamburger right here when you hover that you can edit it if you want to change it. Map additional hosts, like adding another NQN, for instance, you could do that there if you wanted more than one host to be able to access. Since it's an NQN, it's a namespace.
Yeah.
If you wanted more than one host to do that, you could. So the next thing we could do with that storage unit is if you click this hamburger here, protect.
Okay.
You could have done this also as part of the provisioning if you'd selected more options, because then you could click add a snapshot. That'll create a snapshot. That's the name for that snapshot. You
looks
can
like
also
we also-
schedule, and here is a suggested schedule.
Okay. And then obviously we can make our own schedule if we want
you
to.
can, as you like. And then if you go a little further down, remote protection, this is replication to another storage system.
Yeah, in our case, we just have the visibility of one cluster, but if you had a few of them, you could replicate off to another.
And in this case, that replication could be synchronous or asynchronous.
Okay.
And so,
So let's give this LUN a snapshot consistency group. We're just going to call it snapshots.
so what this is doing is it's creating a consistency group, which is what we're going to use as a handle when we do anything involving snapshot or replication. The point of doing it that way is the consistency group is going to have one or more storage units in it. You could essentially replicate 100 storage units with one command by having a consistency group that contains all of those.
Yeah.
And so that way you're able to manipulate all of them by simply manipulating that container.
Okay, cool. Okay, so while the easy steps on the NetApp side, we provision LUN, and after that we have to interact with our RHEL VM. So On that, we had to discover the LUNs, add them, and then now we can finally see them as a NVMe device attached to the host. So overall, pretty easy from the NetApp side. A little bit more OS level items on the RHEL side, but that's NVMe namespace world that we live in.
It's also worth pointing out that you're going to pretty much be doing something very similar to that for whatever storage it is you want to consume using NVMe.
Now that we've gone through the provisioning side of the A90, we're going to look at what it looks like at scale and start applying some load on it and look at some of the tool sets that NetApp offers for monitoring. Okay, Scott, so we've deployed the unit. We're kicking the tires now. So we, as what you explained, we have a 16 LUN setup, each LUN around 160 gig, and we're applying this over how many hosts?
We're applying this across a collection of 8 hosts using multipath, so that way all hosts have access to the same LUNs as the other. And we're also applying a Fibre Channel workload at 16K op size with a read-write split of 80% read, 20% write.
Okay, so we're using this pretty cool tool that NetApp offers. It's Harvest. From what I understand, it's a free tool available on GitHub, and you can use it to monitor the stats of different NetApp arrays.
And that's absolutely correct. The Harvest tool itself is NetApp provided, but it leverages a readily available open source tool called Grafana. And if you go to nabox.org, you can download the actual OVA itself, so that way you can deploy it in your VMware or your favorite virtualized environment. From within there, you got multiple dashboards at your fingertips. One that we're looking at right now is actually at the node level. You also have cluster level, disk level, and a whole multitude of others that are readily available with one click.
So it looks like we have, we're up to about 1.3 million IOPS on the script itself, and we're seeing around 1.2 or so combined on this output. Can you drill through and kind of show off some different stats that are available here?
Sure. So in this case, we have 2 nodes, and of course we have 2 aggregates for those particular nodes. But what you're noticing here is in the lower left-hand corner of the screen is the average CPU utilization. We're pushing this box pretty hard. From here you can see the average latency. Node 2 has a higher average latency, but then as soon as it hits that plateau, it starts to level off. But the throughput per node, green line representing node 1, is holding steady about 11 gigabytes a second, whereas node 2, for whatever reason, is doing almost 11 and a half.
So for an IT generalist who might be an IT admin of many hats, they're controlling a lot of different pieces in their own environment, not really diving in deep into any of them, but having to cover a really wide range of products, how can this help them out?
So if you are in a monitoring station, or you have a setup where you require multiple dashboards to be open at any given time, this is not limited to just ASA. This can monitor all your ONTAP systems, whether they're FAS, AFF, or ASA. But one of the nice things about this is, as I mentioned, you have other canned dashboards that are in there. Maybe your FAS system is more important to you to monitor your disk level, or your SAN is more important to monitor your LUN level. All you would do is go up into, say, cluster, and you could say, oh, I want this cluster. If I had multiple clusters here, they would all show up as a list that I could choose. Or say, I don't really care what happens to node 1. I only want to see what happens to node 2 because I put more storage on that one. Or whatever your preference is. Maybe that one gave you problems in the past, and you just want to keep a sharper eye on that one.
So you're looking at latency spikes, or in this case, high CPU utilization.
Absolutely, yes. And as you can tell here, we had a little bit of a lull where our throughput actually dropped here for a hot minute, but then as the workload increases, it will kick back up. We'll see, you get your IOPS at 1.31 million IOPS a second. At 21.5 gigabytes a second, that's pretty darn good.
Well, yeah. So I mean, in the morning you'd see a lot of I/O activity if it's running VDI sessions. You might see high throughput during backup jobs, or things that are happy at normal times should be happening at those times, and things that where it's like, hey, middle of the day a spike, what's going on?
Absolutely.
We've been with NetApp all day today down here in Raleigh, looking at the new ASA product and getting a better understanding of where it fits in the portfolio and what it's capable of. Kevin, you saw it at Insight when they made the big launch last October. It's shipping now. From your perspective, with all the storage you've administered, just what's your take on that flow in terms of where it would fit into an organization that maybe doesn't have a gray beard with 30 years of storage experience to fine-tune their volumes and
storage
runs?
tends to be easier. I mean, when you add in file sharing or other activities, you do add complexity into users and authentications, and a lot of that just doesn't come in block. So being block only, that does lend to being easier to set up.
And you were up in, I don't know, a few minutes, right, from start to finish. And I mean, I guess if it was in a production environment, your hosts would have access to the storage, and I mean, you'd be going. There's not much else to it.
We provisioned out a storage to a VM, and I think we spent more time just seeing was it on there versus the amount of time required for the array to provision to the host.
We've got a full report on our experience from the day, on what we saw with ASA from setup to a little bit of performance testing, to the Grafana interface, the hardware itself. We took a look at that, as well as positioning to help you guys better understand where ASA fits in the marketplace and in the broader NetApp portfolio. That's on the website, StorageReview.com. Check that out. We're thrilled to have been down here in RTP with NetApp and looking forward to what's next with these guys. There's plenty of great things coming. Expect much more coverage out of NetApp soon.